the vast cosmos of forgotten stories, there exists a clandestine chapter that echoes with the celestial footsteps of the Soviet Union. Brace yourselves, for what many people don't even know is that the Soviet Union stood as the pioneer. The trailblazer, planting its spacecraft on the crimson soil of Mars in the year 1971. The cloak of secrecy shrouding this epochal moment has only recently been lifted, thanks to declassified evidence unearthed by NASA. Join us on a journey through the cosmic corridors of time as we explore the clandestine endeavors of the Soviets on the mysterious red planet. The clandestine Mars mission, spearheaded by the Soviet Union, unveils a saga of triumphs and hidden truths that have reverberated in the silence of secrecy for decades. What were the Soviets seeking on Mars, and why did they choose to guard their discoveries in the depths of classified archives? The revelations are nothing short of astonishing, casting shadows that have lingered in the annals of history, waiting to be unveiled. So, fasten your seatbelts as Universal Narratives embarks on an epic quest to unearth the secrets of the Soviet Odyssey on Mars, a narrative that has remained veiled in cosmic mysteries for far too long. This data shows that the Mars 6 lander successfully touched down on the surface of Mars on March 12, 1974. The lander was able to transmit data back to Earth for 224 seconds, providing scientists with the first atmospheric data from Mars. However, the data from the Mars 6 lander is incomplete. A flaw in a transistor caused system degradation during the journey to Mars, resulting in much of the data being unreadable. Despite this, the discovery of the March 6th telemetry data is still a major breakthrough. It is the first concrete evidence that the Soviets successfully landed on Mars. The Soviets were very secretive about their missions to Mars, and it is likely that they had more success than we have been led to believe. It is possible that they even landed humans on Mars before the Americans. We may never know the full extent of the Soviet Mars program, but the discovery of the March 6th telemetry data is a major step towards uncovering the truth. This is just the beginning. As NASA continues to study the declassified data from the Mars 6 mission, we may learn more about the Soviets' achievements on Mars. It is possible that we will find evidence of other successful Soviet Mars machines, or even of Soviet astronauts walking on the Martian surface. The possibilities are endless, and the discovery of the Mars 6 telemetry data is sure to spark a new wave of interest in the Soviet Mars program. The space race between the United States and the Soviet Union was a time of great technological innovation and achievement. The discovery of the Mars telemetry data is a reminder of that time, and is a testament to the dedication and ingenuity of the scientists and engineers who worked on these missions. It is also a reminder that there is still much that we do not know about the universe, and that we should never stop exploring. The March 6th mission was launched on August 5, 1973, and entered Mars orbit on March 10, 1974, when landers separated from the orbiter on March 12, 1974, and it touched down on the surface of Mars at 2342 UT. The lander was equipped with a variety of instruments to study the Martian atmosphere and surface. These instruments included a thermometer, barometer, accelerometer, radio altimeter, mass spectrometer, and gas chromatograph. The lander was able to transmit data back to Earth for 224 seconds. This data included measurements of the Martian atmosphere, surface temperature, and surface composition. The data from the Mars 6 lander was incomplete due to the flaw in a transistor. This flaw caused system degradation during the journey to Mars, resulting in much of the data being unreadable. The declassified telemetry data from the Mark 6 mission was discovered by a team of researchers at NASA's Jet Propulsion Laboratory. Researchers were analyzing old data from the Mars program when they came across the telemetry data on the Mars 6 lander. The discovery of the declassified telemetry data is a major breakthrough. It is the first concrete evidence that the Soviets successfully landed on Mars, and it raises a possibility that they may have achieved even more than we know. A discovery of the declassified telemetry data is also a reminder of the importance of open access to scientific data. The data from the Mazda 6 lander was originally classified, but it was later declassified and made available to the public. This allows scientists from all over the world to study the data and to share their findings with others. The set of images shows what might be hardware from the Soviet Union's 1971 Mars 3 landers seen in a pair of images from the High-Resolution Imaging Science Experiment camera on NASA's Mars Reconnaissance Orbiter. A possible Mars 3 lander hardware was found by an internet group of Russian citizen enthusiasts who followed news about Mars and NASA's curiosity to open in 1971. The former Soviet Union launched the Mars 2 and Mars 3 missions to Mars, each consisting of an orbiter plus a lander. Both orbiter missions succeeded, although the surface of Mars was obscured by a planet-circling dust storm. The Mars 2 lander crashed, mostly became the first successful soft landing on the red planet, but stopped transmitting after just 14.5 seconds for unknown reasons. The predicted landing site was at latitude 45 degrees south, longitude 302 degrees. The Entalamus's crater high-rise acquired a large image at its location in November 2007. This image contains 1.8 billion pixels of data, so about 2,500 typical computer screens would be needed to view the entire image at full resolution. Agoro from St. Petersburg, Russia, has the largest Russian internet community about curiosity at http://k.com, http://k.com, curiosity.live. His subscribers did their preliminary search for Mars 3 via crowdsourcing. Eagle Rove modeled what Mars 3 hardware pieces should look like in a high-rise image, and the group carefully searched the many small features in the large image, finding what appears to be a viable candidate in the southern part of the scene. An advisor to the group, Alexander Basilevsky of Verta-Tasky Institute of Geochemistry and Analytical Chemistry, Moscow, contacted Alfred McKeevan, principal investigator for HiRISE, suggesting a follow-up image. HiRISE acquired this image on March 10, 2013. The image was targeted to cover up some of the hardware candidates in color to get a second look with different illumination angles. Meanwhile, Basilevsky and Agorov contacted the Russian engineers and scientists who worked on Mars 3 for more information. The candidate parachute is the most distinctive and unusual feature in the images. It is an especially bright spot for this region, about 2.8 yards in diameter. The parachute would have a diameter of 12 yards if fully spread out over the surface, so this is consistent. In the second high-rise image, the parachute appears to have brightened over much of its surface, probably due to better illumination over the sloping surface. But it is also possible that dust was removed during the intervening years, resulting in brightening of the parachute. The descent module, or retro rocket, was attached to the lander container by a chain, and the candidate feature has the right size and even shows a linear extension that could be a chain nearby. The candidate descent module is a feature with the right size and shape to be the actual lander with 4 open pedals. Together, this set of features and their layout on the ground provide a remarkable match to what is expected from the Mars 3 landing. But alternative explanations for the features cannot be ruled out. Further analysis of the data and future images to get better, and also to better understand the three-dimensional shapes, may also help to confirm this interpretation. HiRISE is one of the 6 instruments on NASA's Mars Reconnaissance Orbiter. The University of Arizona Tucson operates HiRISE, which was built by Ball Aerospace and Technologies Corp. Boulder. NASA's Jet Propulsion Laboratories, a division of the California Institute of Technology in Pasadena, manages the Mars Reconnaissance Orbiter project for NASA's Science Mission Directorate, Washington. Lockheed Martin Space Systems Denver built the spacecraft. While the following news about Mars and NASA's curiosity over Russian citizen enthusiasts found 4 features in a 5-year-old image from Mars Reconnaissance Orbiter that resembled 4 pieces of hardware from the Soviet Mars 3 mission: the parachute, heat shield, terminal retro rocket, and lander. A follow-up image by the orbiter from last month shows the same features. The Mars 3 lander transmitted for several seconds after landing on December 2, 1971, the first spacecraft to survive a Mars landing long enough to transmit anything. In 1971, the former Soviet Union launched the Mars 2 and March 3 missions to Mars, each consisting of an orbiter plus a lander. Both orbiter missions succeeded, although the surface of Mars was obscured by the planet-circling dust storm. The Mars 2 lander crashed. Mars 3 became the first successful soft landing on the wet plane. It stopped transmitting after an average of 40.5 seconds. The predicted landing site was at allowed 2 to 45 degrees south longitude, 202 degrees east in Thomas Craner HiRISE, required a large image at its location in November 2007. This image contains 1.8 billion pixels of data, so about 2,500 typical computer screens would be needed to view the entire image at full resolution. Promising candidates for the hardware for Mars 3 were found on December 31, 2012. HiRISE is operated by the University of Arizona Tucson. The instrument was built by Ball Aerospace and Technology School Boulder, Colorado. Mars Reconnaissance Orbiter Project and Curiosity are managed by NASA's Jet Propulsion Laboratory, Pasadena, California, for NASA's Science Machine Directory. The candidate's parachute is the most distinctive feature in the images. It is an especially bright spot for this region, about 8.2 yards in diameter. A parachute would have a diameter of 12 yards if fully spread out over the surface, so this is consistent. In the second HiRISE image, a parachute appears to have brightened over much of its surface, probably due to its better illumination over the sloping circles. But it is also possible that the parachute brightens in the intervening years because dust was removed. The descent module or wrapper rocket was attached to the lantern container by a chain, and a candidate feature has a right size that even shows a linear extension that could be a change. Near the candidate descent module is a feature with the right size and shaped to be the actual lander with 4 open petals. The image of the candidate heat shield matches a shield-shaped object with the right size if partly buried. Philip J. Stuke from the University of West Ontario, Canada, suggested the direction of surgeon offered helpful advice. Arnold Saravanov and Vladimir Monosov helped with access to data archives. If you're as captivated by the cosmos as we are, don't miss out on the latest updates and revelations. Be sure to subscribe to our channel and hit that notification bell to stay informed about the ongoing quest to unravel the universe's deepest secrets. Thank you for watching. And until our next cosmic revelation, keep looking up.